All right, if you're studying technology, you hear about AI constantly, right? It's everywhere. But have you ever stopped to think about how a machine actually learns? I mean, really learns? It's not some kind of magic, it's a process. And today, we're going to break down the three fundamental ways that machines learn. Let's dive in. So, yeah, the big question is, how do you teach a bunch of code to think for itself? How do you get it to adapt, to make decisions, all without you telling it exactly what to do every single time? Well, the answer to that is this incredible field that's changing pretty much everything: machine learning. So what even is machine learning? At its heart, it's a complete flip from how programming used to work. Think about it. Normally, you write strict rules for the computer to follow. If this, then that. But with machine learning, we don't do that. Instead, we just show it a ton of data and say, hey, you figure out the patterns. And the amazing part is, it does. It learns from that data and gets better and better over time. Okay, so let's jump into the first and, honestly, the most straightforward way machines learn. The best way to think about this is like you're in a classroom with a teacher. There's someone there guiding you, supervising you. And that's exactly why it's called supervised learning. Now, the secret sauce for supervised learning, it all comes down to something we call labeled data. And really, you can just think of this as a giant answer key. We're not just throwing problems at the machine. No, we're giving it the problems and the right answers. That way it can start to see the connection, the relationship between the two. So how does this actually work? It's a pretty logical three-step process. First, we feed the model a huge amount of that labeled data, the questions and the answers. Then, the model gets to work, training itself on all those examples to find the patterns. And finally, the cool part. We give it brand new data it's never seen before, and it makes a prediction based on everything it's learned. The whole thing is guided from start to finish. Here's a great example you've probably seen: election exit polls. So the input data, that's the feedback from thousands and thousands of voters. And the label, that's the category they belong to. Did they vote for the winning candidates or the losing one? The model chews on all that training data so it can then predict the final election result. It's supervised learning in action. Now, inside supervised learning, you're usually trying to do one of two main things. First, there's classification. This is all about putting things into buckets or categories. Is this email spam or not spam? Simple as that. The other one is regression. This is when you're trying to predict a specific number, like the price of a house based on its size and location. So categories versus numbers. Two different goals, but they both rely on that same teacher principle. Okay. That's all well and good when you have a teacher and a nice, neat answer key. But what if you don't? What if there's no one to tell the machine what's right or wrong? Well, that brings us to our second method: unsupervised learning. This is where the machine is thrown in the deep end and has to figure things out all by itself. Yeah, exactly. I mean, think about it. Most of the data in the real world is a total mess. It doesn't come with little tags and labels on it. So how on earth can a machine make any sense of that chaos? Well, it starts looking for patterns, for hidden structures all on its own. There's a really great analogy for this from the movie PK. Remember when he first lands on Earth? He's like a newborn baby. He knows absolutely nothing. All he has is the raw data coming in from his eyes and ears. So what does he do? He starts grouping things based on what they look like, their physical structure. He's making his own little clusters of things that seem similar, without anyone telling him, oh, that's a man and that's a woman. And that right there, that's the absolute heart of unsupervised learning. It's a process called clustering. The algorithm just dives into all that messy data and starts grouping similar things together. The amazing thing is, it can uncover these hidden patterns, connections that we as humans might completely miss. And this isn't just a theory, it's super powerful in the real world. Think about it. Companies use this to group customers into segments for marketing campaigns. Your bank uses it to spot weird transactions that might be fraud. That's anomaly detection. And yep, this is a big part of how streaming services figure out what you might want to watch or listen to next. It's all about finding those hidden groups. All right, on to our third and final type. This one is completely different. It's all about learning from experience, from pure trial and error. Think about how you learn to play a video game, or how a pet learns a new trick. This is reinforcement learning. So here's the basic idea. You've got an agent. Let's say it's the AI in a self-driving car. That agent performs an action out in the world, the environment. And for every single action it takes, it gets feedback. It gets a positive reward for a good move, like staying in the lane, or a negative penalty for a bad one, like swerving. And its one and only goal? Get as many rewards as possible. Let's go back to our PK analogy for a second. This is a perfect example. He performs an action, he gives someone a 50 rupee note, he gets a reward, some carrots. Awesome. He's just learned a rule, what we call a policy. But then he tries giving someone just a picture of Gandhi, and it totally fails. He gets a penalty, no carrots. So he updates his policy, right? He learns, okay, the value isn't just in the picture, it's in the specific piece of paper. That's learning from consequences. This kind of learning is behind some of the most mind-blowing stuff happening in AI today. We're talking about AlphaGo, the AI that taught itself to beat the best human Go players in the world. It's how advanced robots are learning to walk, even on rough ground. And it's absolutely critical for self-driving cars that need to make those life-or-death split-second decisions. Okay, so we have gone through the 3 big ways machines learn. Let's do a quick recap and put them all side by side so you can really see the differences. This table basically sums it all up. Look, you've got supervised learning, you give it labeled data, and its goal is to predict outcomes based on direct feedback. Then there's unsupervised. You give it unlabeled data, and it just finds the hidden patterns on its own, with no feedback. And finally, reinforcement learning. There's no data to start with. It learns a policy by getting rewards and penalties from its actions. This is your perfect cheat sheet right here. But you know, the real world is messy, and things aren't always so black and white. So what about the middle ground? Well, there's actually something called semi-supervised learning. Think about it. Getting all that perfectly labeled data can be really expensive and take forever. So this clever approach uses a tiny bit of labeled data to help make sense of a whole mountain of unlabeled data. It's a really practical way to get the best of both worlds. So there you go. Those are the 3 core ways that machines learn. Each one is an incredibly powerful tool in your toolkit. The real trick, the real art, is knowing which one to pull out for the right problem. You now have the map. The only question is, which problem are you going to solve first?